Ever look at an old cathedral or even a super modern skyscraper and just wonder, how is that thing still standing? Well, the secret isn't just in the design. Nope, it's locked deep inside the very stones they're built from. So let's get into the science of how we find the perfect rock for the job.
I mean, that's a huge question, right? This is not like picking out paint colors. You're making a decision that has to stand up to centuries of sun, rain, and freezing ice. The choice you make right now determines whether you're building a future ruin or a timeless landmark.
So, what are engineers and architects really looking for? Well, you can think of it like they're holding a job interview for a piece of the Earth's crust. And believe me, the job requirements are incredibly strict. Okay, so here's the checklist for the perfect stone. It needs to be hard, to resist scratches and daily wear and tear. It's got to be strong enough to hold up immense weight without even thinking about cracking. Of course, it has to be durable enough to last for generations. It must resist weathering, have a fine, compact texture, and this one is absolutely key, it has to be workable. Seriously, you can have the strongest stone in the world, but if you can't cut it or shape it, it's pretty much useless.
But where do all these amazing qualities even come from? Well, to understand a stone's strength, you have to go back in time. We're talking millions of years back, to see how it was born. A stone's entire resume is written in its geology.
First up, we've got igneous rocks, which were literally born from fire. These are formed when molten magma cools down and becomes solid. Think of something like granite. That super slow cooling process creates this dense, interlocking crystalline structure, which makes these rocks incredibly hard and strong. They're basically the heavy hitters of the rock world. Next up are sedimentary rocks. You can think of these as being forged by pressure. Over millions and millions of years, tiny little particles of sand, shells, and other bits of debris settle down in layers. The incredible pressure from everything piling up on top compacts them into solid rock, like sandstone or limestone. And those layers, they tell a huge part of their story. And finally, we have metamorphic rocks, the great transformers of the bunch. These guys start out as either igneous or sedimentary rocks, but then they get subjected to extreme heat and pressure deep down inside the earth. This whole process basically recooks and reorganizes their minerals, changing them into something totally new. It's how limestone turns into beautiful marble, or how shale becomes slate.
So here's the bottom line. These different origin stories create totally different internal structures. Sedimentary rocks are often stratified, which just means they have these distinct layers. Now that's fantastic if you want something like slate, which you can split into those perfect thin roofing tiles. But for a massive, load-bearing column, you want an unstratified rock, like granite. Just a solid, granular block with no weak planes at all.
So, knowing a stone's origin story is step one. Step two is putting it through a series of absolutely brutal scientific tests to see if it's really cut out for the job. This is where geology meets hardcore engineering.
Right. We can't just look at it and guess. We need data. We need to push the stone to its absolute limits to find its breaking point before it ever goes into a building. And as it turns out, one of the most revealing tests is, well, surprisingly simple.
I know, it sounds almost too basic, doesn't it? But trust me, this single test can tell you almost everything you need to know about how durable a stone is going to be. It all comes down to its relationship with water.
So why water? Because how much water a stone soaks up reveals its porosity, basically how many tiny holes or voids it has inside. A really porous stone acts like a sponge, and when that trapped water freezes in the winter, it expands with incredible force, slowly and powerfully breaking the stone apart from the inside out. That process is called frost action, and it is a building's absolute worst enemy.
Because of that danger, there's a hard and fast rule. They take a stone sample, weigh it, soak it in water for 24 hours, and then weigh it again. To even be considered for construction, that stone cannot absorb more than 5% of its own weight. It's a clear pass or fail. But for the best of the best, the kind of stone you'd use for a national monument or a critical bridge, the standard is way, way higher. The goal is an absorption rate of less than 0.6%. Think about that. That's the difference between a material that lasts decades and one that can last for centuries. It just shows the gap between a material that's just acceptable and one that's truly exceptional.
Okay, so let's tie all of this together, because when you match these incredible natural properties with a very specific purpose, that's when you get the iconic structures that we all recognize.
You see, every stone has its own kind of superpower that makes it perfect for a specific job. Granite's incredible hardness makes it the go-to for monuments. Slate's amazing ability to split into those thin, perfect sheets is why it's the ultimate choice for roofing. Sandstone is a bit softer and easier to carve, so it's perfect for those intricate building facades. And marble. Its fine grain, its ability to hold the most delicate detail, makes it the timeless choice for statues.
So you see, it is never, ever a random choice. An engineer is actively and deliberately matching the stone's geological past, its origin story, to the future that they are trying to build.
So now that you're armed with a bit of this science, you can start to see your own city, your own neighborhood in a completely new light.
Here's the big takeaway. Every stone step you walk on, every stone wall you pass, every monument you see, they all represent a series of very deliberate choices. They are a testament to our ability to read the story of the Earth and then use that story to build our world.
So next time you're walking down the street, I want you to take a closer look. Is that granite holding up a bank? Is that slate protecting the roof of an old house? Every single one of those stones has a multi-million-year-old story to tell. What are the ones in your city saying?